Hello, this is Mr. Stansbury. I'm going to take you through the notes on proving special quadrilaterals. Okay, at the end of this, you should be able to say I can prove parallelograms, rectangles, rhombuses, and squares. Okay, so first thing, let's just get straight into some examples. Prove that P, I, G, and S is a parallelogram. Okay, so first thing we're going to need to do is remember what a parallelogram is. That's a quadrilateral where both sets of opposite sides are parallel. Okay, so probably our best bet to doing this is if you graph this, it becomes pretty easy to see what's going on, and it also becomes a little bit easier to see what the slopes of all the lines are. Okay, so let's graph this thing. P is at -1, 0. Let's see. I'm not sure where these are going to be. Let's see. I think we're going to be okay here. Let's do P. I is at 5, 4. Okay, so that's I. G is at 9, 2. And then S is at 3, -2. Okay, so we've got this thing here, which is going to make a parallelogram. At least it's supposed to. We're going to show that it is a parallelogram. First, let's draw the sides so it makes it a little easier to see. Okay, so there's our parallelogram. So we just have to show that this side is congruent, has the same slope as that, and this side's got the same slope as that. So, really, probably the easiest way is just to use our rise over run. So I'm going to start with, like, if I'm going to do PS and IG. So let's do PS, the slope of PS, and the slope of IG. Okay, so these are slopes. Okay, so if we're going to go PS, I always like to start on the left and move to the one to the right. So to start the one on the left, we go, if we're going to do rise over run, we're going to go down 1, 2. So it's going to be -2 over 1, 2, 3, 4. So it's -2 over 4, which is -1/2. Okay, so for IG, we'll do the same thing. Start on the one on the left. To get from I to G, we go down 2. And we go over 1, 2, 3, 4 as well. So that's -2 over 4, which is also -1/2. So since both of those have the exact same slope, we know that these two sides here are indeed parallel. Now we got to do the same thing with PI and SG. So the slope of PI and the slope of SG, right? Okay, so from P to I, start with the one on the left, go up 1, 2, 3, 4, or up 4, and then over 1, 2, 3, 4, 5, 6. So it's 4 over 6, which is 2/3. And then from S to G, start with the one on the left. We're going to go up 1, 2, 3, 4. And over 1, 2, 3, 4, 5, 6, which is also 2/3. So since these two equal each other and these two slopes also equal each other, we have now shown that these opposite sides are parallel. So that means it has to be a parallelogram. Okay. Another way you could do this without graphing is you would just have to, excuse me, you'd have to go through, and since it's all going to be in order, this P to I to G to S, that you would always pretty much want to match the first and the third. Excuse me, that was not right. We'd go with the first and the second together, and then the second and the third together. Sorry, the third and the fourth together. So PI, and then GS, that would prove these two. And then we would want to go, let's see, these middle two here, and then the first and the last one also together. That's going to prove the other ones. So you can kind of tell it's probably going to be easier just to put a little graph out there and then quickly find the slope, show that they're the same. Okay, but again, you can do this with the slope formula. Okay, let's take a look at another example here. prove that NEAT is a rectangle. So again, what we want to do is we want to know what, each one of those things, we want to know what a rectangle is. Okay, so here we go. We've got a rectangle is a quadrilateral with 4 right angles. Okay, so there are also some theorems that help us prove rectangles. Okay, if one angle of a parallelogram is 90 degrees, then all angles have to be 90 degrees. Then all angles are 90 degrees, so therefore it has to be a rectangle. So if we can prove that it's a parallelogram and prove that one of the angles is 90 degrees, then we can prove that it's a rectangle. Or if the diagonals of a parallelogram are congruent, then we know that it's a rectangle. Okay, so either way, we've got to show that it's a parallelogram. So let's start with that. I would say our best bet, again, is let's just go through and graph these points. How about this? Before we do this, let's do a quick little comedy break.
This middle of the afternoon, we'll just stop and go, Daddy, can I talk to you for a second? I'm like, yeah, what's up? She goes, I just want you to know I love you. Yeah, and I'm like, are you kidding me? I love you. And she's like, no, I love you so much. I'm like, I love you so much. And she's like, no. I love you more than brownies. I was like, thank you. I love you more than gluten-free brownies. What do you say? I don't know what to say.
All right. So let's see. So let's graph these things here. So -5, 1 is our N. -3 and -3 is E. 6, 0 is A. And 4 is T. Okay, so let's connect all these dots here, and then let's try to see if we can prove that it's a rectangle. Okay, so here's what we've got here. So first off, let's let's go through and show that the sides are parallel, right? So let's go. Slope is often referred to as M, not measure, but M for slope. So the slope of NT. Slope of NT is going to be, so to go from, always start with the one on the left, go to the one on the right, up 1, 2, 3. It's rise over run, so it's always up and down first, up 3, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 3 over 9, which is a third. And then let's do the slope of EA. Or AE, doesn't matter. Start with the one on the left. Up 1, 2, 3. And over 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 3 over 9. So that one is also 1/3. So we have now shown that those two sides are parallel. Okay, so now let's show that NT and EA are parallel. So the slope of NT and the slope of EA. Okay, so from, those are the ones we just did. Let's try that again. So slope of EN and the slope of AT. Right? So E and N, N's on the left, so we're going to go start with that one. So we go down 1, 2, 3, 4 over 2. So -3, sorry, -4. So we went down 4 over 2, so -4 over 2, which is -2. And then from T to A, down 1, 2, 3, 4 over 2. So -4 over 2 as well, which is also -2. So we have now proven that it is a parallelogram. And then the last part is we have to show that it's a rectangle. So we have to show that these are 90-degree angles. Okay? So in order to show that these are 90-degree angles, That means our two slopes have to be inverse reciprocals of each other, if you'll remember. So 1/3, right? Or actually, even an easier way is if you multiply the two slopes, it has to equal -1, right? So if you take, but problem is, if we take 1/3 times -2, we get -2/3, which does not equal -1. So therefore, this is not a rectangle. Okay, so not a rectangle. It is a parallelogram, but it is not actually a rectangle. So we cannot prove that one. We've actually proven that it's not a rectangle, though, since the slopes are not inverse reciprocals of each other, and the slopes do not multiply together to give us -1. That does not work. Okay. All right. We'll do a couple other ones here on part 2 of this video. But if you have any further questions on this, please feel free to ask in class.